Good morning, students. So, in the previous video, we were talking about the flow of current. Due to some power cut, due to some problem, the power was cut, and the video was cut in the middle. So let's continue with the next part, that is the mechanism of current flow. So in the previous video, we have ended up with this equation, that means the drift velocity is equals to minus E electric field by M into tau. What is tau? Tau is the relaxation time that we have discussed in the previous class. This is the relaxation time. Tau is the relaxation time. And I have said that though the electron is under electric field, and due to this electric field, the electron is experiencing a force, but this drift velocity, it is a uniform velocity. Though the electron is under force, but the velocity attained by the electron is a uniform velocity. Why? Because of its collision. So when the electron is moving or flowing inside a conductor, this electron will experience a number of collisions, and at each collision they will lose the velocity and they will maintain a steady velocity, and this velocity is called drift velocity. Here, so this drift velocity, this is drift velocity. So this drift velocity is a uniform velocity. Okay. Now, our today's topic is that we will see that the Ohm's law is valid in case of conductor. Suppose what Ohm's law said that temperature, pressure, and all other physical factors remain constant, then the amount of current flowing through the conductor is directly proportional to the potential difference maintained at the two ends of the conductor. Here, so amount of current is proportional to potential difference. Okay, so today we will see that yes, the Ohm's law is very much accurate, it is very much valid in case of conductor. In case of semiconductor, in case of insulator, this Ohm's law is not valid. So that's why conductor is also called the metals. Maximum metals are the conductors. So conductor is also called ohmic conductor. Okay, because it follows Ohm's law. Clear? So this thing we have already known. Okay. Now today we will derive this. So let's first make a draw of a conductor. Okay. So this is a conductor. Okay. Now I will make an area out of it, cross section, and also cross section. Area. This is also a cross section. So this is one cross section, this is another cross section. Now I have taken a conductor having uniform cross section. Okay. Now Ohm's law is valid for non-uniform cross section of conductor also. If the conductor is of non-uniform cross section, then also the Ohm's law valid. So here we will take the uniform cross section. Clear? So here we will take a uniform cross section whose cross sectional area is A. Clear? And the distance, suppose, now see what will happen, the electron will flow, clear? So inside the conductor, if I maintain a potential difference, suppose I have applied a battery. So I have applied a battery. Okay. So inside the conductor there is a steady flow of electron here. So the electron, that is the electron is moving here, the electron is getting into it and the electron is getting outside from this surface. That is number of electron getting inside is equals to the number of electron getting outside here. So this is a steady flow of electron here. So suppose at time t equal to 1 second, some number of electron getting inside through this first cross section, some number of electron getting inside through this is the first cross section, this is the second cross section. Okay, so suppose that t equal to 1 second, some amount of electron will pass through this first cross section and become accumulated here. Suppose at t equal to 1 second, that this number of electron will pass through the first cross section and this accumulated here. Now at t equal to t second, what will happen? This amount of current, that is suppose not t equal to 3, suppose t equal to 2 seconds, and the second t equal to 2 seconds, this amount of electron will pass through this conductor, so this second surface area, second cross section, and the same amount of electron from this side will get inside through the first cross section and accumulated here. Just think clearly. Suppose t equal to 1 second, the electron will pass through the first cross section and come into here. At the second, that means at the next second, all these electron will pass through the second cross section, and the same amount of electron will pass through the first cross section and accumulated here. So at t equal to 3 seconds, this will again flow and another set of electron will move into this. Okay, so this is called the steady flow. Steady flow means there is at every electron, okay, at every point the electron having same velocity. At every point the electron having same velocity. So number of electron getting inside through the first surface is equals to the number of electron getting outside through the second surface. Okay, so this is actually the next. This is actually what the steady flow. Okay, now if this distance is L, okay, and now we know that. So we know that the electron having the velocity, drift velocity, that means can we say that L equal to drift velocity into tau? And we say, sorry, not tau, drift velocity into t. The t, what is t? T is actually 2 minus 1 here. Now suppose this is at t second. At first second, the number of electron getting inside, then at the t second, this electron will move outside. Okay, so this L will become drift velocity into time. Okay, can we say that Vd is the drift velocity, that is the electron having that velocity, that amount of velocity. So what will happen? Now we know that current is equals to charge by time. Okay, charge by time. That means at t second, how many number of electron is passing through this surface? At time t second, that means at time interval t, how many number of electron is passing through this surface? Okay, so this number of electrons will pass through this surface at time equal to t second here. Okay, so this number of electrons will pass through this surface at time t second. Okay, so let's say this is n into E by T. Can you see? N is the, let N is the number of electrons passing through A2. N is the number of electrons passing through A2, that is, it is this area, clear? Now, this N, and if N equal to number density of electrons, if N is the number density of electron, then how many electrons, if N is the number density of electron, then how many electron is there inside this volume? This is one surface and this is another surface. Clear? So inside this volume, how many number of electrons are there? And that number of electrons will pass through this A2. Okay. So this N equal to N, it is number density into volume. What is the volume? Volume is area into L. This is volume. Area into L. This is the volume of this cross-sectional cylinder. Okay. Into E by T. Okay. Now N into A into L can be written as drift velocity into time. This T and this T will get cancelled out. Now it is coming N A V D into E. Therefore, current equal to N A drift velocity into E. This we have attained. This is equation number just 1 and 2. This is equation number 1 for this case. Okay. So calculation, you will have to repeat from the first. How we have find out this calculation? What are the steps that you have to follow? Okay. So this is the two cross section I have taken. Now we have to understand what is steady flow. That means number of electrons passing through this surface area should be equal to number of electrons passing through this surface area also. Here, then only no accumulation of the charge will be takes place. Okay, so this is the steady flow, and from there I have defined what is the L. L is the drift velocity in time. Okay, N is the number of electrons passing through the A2. Okay, N is the number density, and we have calculated this and ended up with that current is equal to N A V D into E. Okay. Now, now we will understand a second term. So I am running this. So this equation will get. Now the second term, that is mobility. What is mobility? Mobility means it is the ratio of drift velocity by electric field applied. Mobility means ability to move. Obviously, mobility means ability to move. So, an electron, it will have the ability to move, and this ability that is defined by mobility. That is drift velocity by electric field applied. That means per unit increase in electric field, how much change in drift velocity This is the mobility. Clear? So, if I change a small amount of electric field, then how much drift velocity will change? That means drift velocity means how much the electron velocity will change. This will defined by mobility. This is actually the mobility. So, the mobility is denoted by mu. It is denoted by mu. Okay. And we know that drift velocity is Vd and E. So, Vd can be written as mu into E. Now put this value here. What we will get? I equal to number density of the conductor, area, cross-sectional area of the conductor. Now Vd, in place of Vd we have to put mu into capital E into small e, that is the charge of the electron, a single electron. So now see, now what I have taken, suppose this is my conductor and the cross section area that we have taken. Okay. Now this is the length that we have to. This is the length. Now if the potential difference, so this is V1 and V2. If this amount of potential difference was maintained at the two ends, okay, and if the electric field that was applied is E, then we can say that this potential difference change, that means V2 minus V1, sorry, higher potential to lower potential, that means V1 minus V2. Okay, this should be equal to E into L. Actually we know that electric field applied is equals to potential difference change by L. Here. So this is written as N A E into mu into potential difference change in potential difference by L. Here. This was the relation between the potential and the electric field. In the previous class, in the previous chapter, we have already studied what is the relation between the potential difference and the electric field. Here that we have already learned. Okay. So from that relation, we got this equation, and this equation we have put this inside into this equation. So what is it? It is NAE mu into delta V by L. Here. So this is I. Here. This is I. So I equal to N A E into mu into by L into what? Delta V. So delta V, that is potential difference, is equals to L by N A E into mu into I. Okay. Now see, N is the length of the conductor. Here, N is the number density of the conductor. A is the cross-sectional area of the conductor. E is the electronic charge, and mu is the mobility of the electron. Now see, in a specific conductor, suppose I am taking about the copper conductor. Okay. So which one is the best conductor? Which one is the best conductor? I know that metals are the conductors, I can say. Okay. So which one is the best conductor? silver is the best conductor. Now after silver, the copper is. Okay. Now this now for a suppose I am taking copper conductor. So for a copper conductor, all this factor, that is length of the conductor, that is number density of the conductor. You see, in Ohm's law, what I have said, that temperature, pressure, and all other physical physical factors remain same. Now, physical factor means for a conductor, the length, that is a physical property. For a conductor, the length is a physical property, so length should be remain constant. I have said number density. Now, for a specific temperature and pressure, the number density of the conductor should be remain constant. Obviously, the number density will change with pressure and temperature. Okay. Now, in Ohm's law, I have said that in Ohm's law already it is mentioned that temperature, pressure, and all other physical factors remain constant. So, number density will be remain constant. Cross-sectional area is again a physical factor. It is also remain constant. Electronic charge, obviously it will remain constant. Okay. For electronic charge, it is remain constant. And mobility, obviously the mobility is the ability to move. Mobility means ability to move. So it will depends on temperature and pressure. And in Ohm's law, I have said that temperature, pressure, and all other physical factors remain constant. So mobility will also remain constant. So these all are the constant term. So I can say delta V is proportional to I, and this is the Ohm's law. This is the Ohm's law. And what I have said, that potential difference change equal to I into R. This is the what? This is what resistance. This is what resistance. Now compare this with this equation and this equation, compare it. What we will get? We will get R equal to L by N A E into mu. Here, this we will get R equal to L by N A E into mu. Okay, this is the expression of resistance offered by the conductor. Here, offered by the conductor, and actually, if you see in the previous video, I have drawn the environment inside a conductor. So inside a conductor, electron is there and also the kernel is there, and the position of the kernel is fixed. It will not move, only the electron will move. So this resistance, actually when the electron moves, it will get collided with the kernel, it will get collided with the other electrons also. So this collision is the source of this resistance. Here, so this resistance, it has source from the collision. Here. So this expression, now look carefully. So Ohm's law, we have already deduced now Ohm's law. L N A E into mu. Now see 1 by N E into mu. L by A. Now see, this term also it is constant, and we know that R equal to rho L by A. This we have already learned. For a conductor, for a specific conductor, for a conductor, R, that is resistance, is equals to rho L by A. So what is rho? Rho is the specific resistance. Rho is the specific resistance. L is the length of the conductor, and A is the cross-sectional area of the conductor. A is the cross-sectional area of the conductor, A is the length of the conductor, and rho is the specific resistance. Okay. So if I compare this and this equation, but I will get specific resistance is equals to 1 by N E into mu. This is the specific resistance. Here, this is the specific resistance that we have got. Okay. So specific resistance depends on the number density of the electron, charge of the electron, and the mobility of the electron. Here, so for different material, suppose I am talking about silver or copper. For different material, this number density will change, this mobility will change. Obviously, the charge of the electron will remain constant for all the conductors. But if you change the conductor, if you change the materiality of the conductor, that means if I shift from silver to copper, then these values will change. Here. Okay. So again, if the number density of the electron will increase, then the resistivity will decrease and the resistance will also decrease. The same thing, so simple physics is behind. So what is so resistance we have got resistance what is the resistance? Resistance is L by N A E into mu here. So resistivity or specific resistance equal to what? 1 by N E into mu. Okay, this is the resistivity. Okay, so what is conductance? Conductance equal to N A E into mu by L, and conductivity equal to N E into mu. This is conductivity. Okay? So again, the unit is ohm. Okay, and it is what? Ohm. Sorry, ohm meter. Okay, or Siemens. Or Siemens, it is the unit. It is ohm inverse, and it is ohm inverse, meter inverse. Okay. So this is the unit of resistance and conductance and resistivity and conductivity. Okay. Now which have high conductivity, it should have lowest specific resistance or resistivity. It is inversely, they are inversely proportional. Now, what are superconductors?